All right, welcome back, ladies and gentlemen. We are doing one of my favorite sections here because it does get us ready for graphing, and it's talking about slope. Now, slope is a fancy way of writing a ratio. If you remember, that's really just a fraction. Rise over run is the key terms. Maybe you've heard that before. We'll get to that in just a moment. Our objectives, I will find the slopes of lines, and we're going to focus on finding the slopes when we have a graph. We're going to look at one problem that if you don't have a graph, what would you do? But we're really going to make a graph. In 8th grade, you're going to focus on the graphs and just the actual numbers given to you, meaning you don't have to make a graph to do that. But that's in 8th grade. So let's see here. Opening questions. Have you ever been skiing? I haven't been skiing for years, but I have experienced mountains, especially in my awesome Spartan races, missing them from this year, but going uphill and downhill. So it says, what is the difference between a beginner's trail, often called the bunny slope, and the expert's trail, often called the black diamond? Now, here's a funny story about me learning to ski. In high school, I went on a youth trip with our church and we went skiing. I have never been before, and my friend tells me, don't worry, I'll teach you. So instead of taking me on the bunny slope for the beginners, what does he do? Oh, yeah, he takes me on the black diamond slope. I am scared out of my mind, but a little excited at the same time. All I could do is go down a little bit and then turn to the left. Sit down, get back up, reposition myself down and to the left. I did not know how to turn right yet. Could not go down very well, like the awesome slalom style, back and forth, but it was crazy. It was very steep. It says which one of the two would have a steeper slope. Now, obviously, we know it's the black diamond, right? But the question really that we want to do is, can we calculate the slope of a trail? Now, instead of watching the video, we're just going to move on to the actual calculation of the slope, which we call rise over run. The rate of change, or our slope, can be found in many different parts of life, not just a hill or a mountain, but it's also on the roof of a house, apartment, any type of structure. You don't want it to be too steep, but it's got to be steep enough. Now, it doesn't really want to be a flat roof because a bunch of rainwater, whenever it rains in Southern California, would get stuck up top. Got to have a nice slope there. But not so much like when I went up on our roof to get the Christmas lights up. It was an okay slope, wasn't too steep, but still a little nervous. If it was a really steep, I don't know how that would have gone. The slope again is vertical change is y, which we call the rise, over a vertical change of x, which we call the run. Now, in 8th grade, we still call it rise over run. We still talk about the rise being the y and the run being the x. In high school, you're going to use a little bit different terminology, but it still does refer to the y-axis and the x-axis. Rise over run. Now, you should have had experience with graphing from elementary school, like maybe you had to plot some points about how many frogs are on the lily pad. That's really when you're just focusing on your positive numbers. But in 7th grade and 8th grade, we also start including the negative numbers. But we can still calculate the rise over run. So here's a silly little graphic. Let's see. Positive slope. Puff, puff, puff. Because again, it's difficult climbing up. We read from left to right. Positive slope going up the hill. Then when you reach the hill, negative slope. Again, we're still reading left to right, going down the hill. This horizontal part is called a zero slope. Boring. And then slope, instead of saying not defined, we usually say undefined. And I want to learn how to go parachuting, skydiving, but I have to wait until all my kids are 18. Safety reasons. I'm so excited though. This is a better example for what we're actually going to be doing with our assignment in the textbook and IXL. Positive slope, again, we read left to right. Looks like you're going up that hill, like that silly little graphic. Negative slope, down the hill. Zero slope, that's that boring horizontal part. There's no vertical change at all. It's pretty boring. That's why I don't like running on the street. It's just like, oh yeah. And again, this is the craziness, the undefined slope. It's like that parachute. It's just a vertical drop. Whoa. No change left or right. It's just a vertical drop. So horizontal line, boring, running, zero slope. Vertical line, vertical drop, exciting, undefined slope. Maybe you can say it's so exciting you don't know how to explain it. It's undefined. All right, finding the slope of a line. We are going to be doing, again, counting rise over run. Now, this quick information here shows you that there's really two ways that you can find it, but I prefer one over the other. But if you notice, you're still going to end up with the exact same slope of 1/2, or 1 over 2. Rise is 1 and the run is 2. And you can find that by doing the rise, then the run. Or you can start at the other point and do the rise, which is negative, and the run. So you know what? We really don't do that. I'm not too sure why this graphic is here. We don't run to the left. We always run to the right. So the other method would really be running right and then rising up. So let's focus on that. Let's do the rise first. So if you notice on this graph, we already have our 2 points visible for us. The numbers can be used, but really it's the boxes that we're going to be counting. So I want to make a right triangle to get from this point here to this point here. That's also going to help you out in 8th grade and in high school. This right triangle is going to be the rise over run representation. So the rise is going to look like this, and that's 2 boxes. The run is going to look like this. And that's going to be, let's see, starting from the y-axis, 1, 2, 3, 4, 5 boxes. Now you don't have to put the little arrows there if you don't want to. In fact, I encourage my students not to do that, but that shows the movement. So I'm rising up and then running to the right. So if my rise is 2, my run is 5, I ask myself, can I reduce this? No. We don't want a decimal answer. We want a fraction answer. So even if it comes out to an improper fraction, we're going to leave it like that. We don't want a mixed number. We don't want a decimal. We want a nice fraction. Rise over run. Because the numerator is the rise, the vertical change, and the denominator is the run, or the horizontal change. If you notice this one, though, it does look like it's going downhill. In fact, it looks pretty steep. So what I like telling my students is reading left to right, going downhill, negative slope, pretty steep. That tells me it's going to be an improper fraction. Where this previous one, it went uphill, positive slope, and it doesn't look very steep at all. It's a nice gradual hill. This would be a scary slide. Ooh, that'd be fun. Maybe a roller coaster. All right, let's see here. Slope, again, is rise over run. I'm going to start here on the first point, and I want to move to the second point. I'm going to be creating a right triangle. So I'm going to go down. Let's see, how many boxes is that? 1, 2, 3, 4, 5, 6, 7. Now, as silly as it sounds, some students don't know how to count on these problems. So let me show you one more time how to do it. Down 1, 2. In other words, when I'm moving a full box, I say 1, 2, 3, 4, 5, 6, 7. Now, the reason I bring it up is because some students, even 8th graders, they go like this. 1, 2, 3, 4. In other words, they're going to get the wrong count because you don't count until you move the box. I know it sounds silly, but it is. Now, again, it's 7 boxes, but it's negative because I'm counting down. We already know it's a negative slope, so our answer better be negative. Running to the right. So let's see, that's going to be 1, 2, 3. Negative 7 over 3. I cannot reduce that. I do not want a mixed number or decimal. I'm going to leave it as negative 7 over 3. Now, that might be a little bit different for you, but the good news is it's less work that you have to do. Again, it's just a ratio. That's all we're finding. It's connected to our other fraction skills. All right, let's see. Find the slope. Going uphill, positive. Kind of steep, probably an improper fraction. Let's count the rise and the run. So let's see. Remember, starting from the dot, got to move a box. 1, 2, 3, 4, 5, 6. Looks like 6. You may want to count more than once. Don't have to, but 1, 2, 3, 4, 5, 6. So the rise is 6. Positive, right? Counting uphill. We're always going to run to the right. Let's see here. 1, 2, 3. Well, 6 divided by 3 is 2. 2 over 1 is an improper fraction, right? But our preferred answer is usually just 2. But the 2 over 1, that shows us it's an improper fraction. Because remember, I told you a steep line or a steep slope would be an improper fraction answer. Excellent. Ooh, this one, I don't have the dots ready for me, but I need to make the graph, then find the slope. So let's see here. All right, if I'm going to make the graph 0, 4, that starts at the origin. 0 means no x movement. So that would be up 4. 1, 2, 3, 4. Put your dot. 4, negative 2, back to the origin. That means x is 4, so I move to the right. 1, 2, 3, 4. But negative 2, down 1, 2. So remember, it's x and then y. So 0, 4, like I showed you, is right there. And 4, negative 2, that's right 4, down 2. You're going to connect it. You got a nice line now. We want to make our right triangle. Now I notice downhill, negative slope. Might be steep. Not too sure. Maybe a little steep. Let's see. Counting your boxes. 1, 2, 3, 4, 5, 6. Run. From the corner, 1, 2, 3, 4. Positive 4. Because again, we're always running to the right. Positive. I can reduce this. If you leave it as negative 6 over 4, sorry. Need to reduce it. Dividing by 2. We practiced that again just yesterday. Negative 3 over 2. That is a negative slope. It's an improper fraction, so it is a little steep. All right, let's try another one. Negative 2, 5. So back to the origin. Negative 2 for the x means left 2. And then positive 5 means up 5. 1, 2, 3, 4, 5. Nice, right there. Back to the origin. Negative 2, negative 3. So I'm going to go left 2, 1, 2. Then down 3. 1, 2, 3, because it's negative 3. Make your line. Oh, what do you know? It's a special one. The horizontal lines and vertical lines are the special one. Now remember, when it's a horizontal line, that's like that boring running, which is a slope of 0. But since this is a vertical line, it's going to be that other special one. You can't describe it. It is indescribable or it is undefined. But to verify that, we know that the rise over run. So our rise is 1, 2, 3, 4, 5, 6, 7, 8 spaces or 8 boxes. My run, well, I didn't run to the right at all, right? It is just 0. Now, what we like telling our 8th graders is if 0 is under the line, it is underfined or undefined is the way that we really write it. Under the line, underfined. Under the line, underfined, or undefined. It's that exciting one. You can't define it. I can't imagine what it's going to be like when I get to actually go skydiving. It's going to be awesome. Undefined. If it's horizontal, that's that boring 0. Running on the road. Yay. Let's go mountain running. All right, so if you remember, uphill, positive slope. Downhill, negative slope. Horizontal, boring running, slope of 0. Vertical, exciting parachuting, undefined. Can't describe it, it's undefined. All right, we did this Other one, let's just do it real quick. Negative 3, 1. Remember, that's the x, y. So that's left 1, 2, 3, up 1. 5, 5, back to the origin. 5, 5 means right 5, up 5. 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 5, 5. Connect it. All right, this is a pretty big spacing, but we're going to count it again. Rise over run. Let's see, up 1, 2, 3, 4. Rises 4. Run from the corner. 1, 2, 3, 4, 5, 6, 7, 8. Now, 4 over 8 is not an improper fraction, but we do need to reduce it, and it'll come out to a nice 1/2. The rise is 1, the run is 2 when we reduce it. Nice slope, 1/2. So remember, those uphill, downhill, very helpful for you to understand if it's a positive uphill, downhill is negative. All right, be awesome.